Hello everyone, welcome to the video tutorial for the Canary Release milestone 3. So as part of this video, we'll enhance the features for the deployment that we did, and we'll add the feature to perform a Canary Release for the checkbox.io application, and we'll use a proxy load balancer in front to route the percentage of traffic to the Canary version as well as the stable version of the software. And if we have any problems related to the Canary instance, we're going to route all the traffic to the stable instance. So before we go and run the playbooks, I'll just quickly show you the design and implementation of this Canary release. So we have this developer here. So we'll have two branches to the Git repository. One that corresponds to the master and the other one is the Canary. So whenever he pushes changes to either of these branches, Jenkins server is going to poll these two branches for any changes. If there is any change detected, it's going to build it locally, and then it is going to provision a new visit instance in AWS and then push the code to the new visit instance. So the master branch will always have the stable version of the code. Developer will push the code into the Canary instance, Canary branch. Jenkins server is going to provision a new Canary instance and will route some percentage of the traffic to the Canary instance. Once that is being tested in the production, we'll push it to the master and we'll push it to the stable version. So let's get back to the YAML files. So I have a configuration.yaml file which is going to configure the Jenkins server as well as a load balancer in an EC2 instance. Post that, the Jenkins server is going to build jobs for the checkbox.io application, and since we have two branches, master and Canary, it's going to provision two new instances in the AWS, and it's going to run the applications in those instances. Let's trigger this playbook for now. We'll look at the configuration.yaml file meanwhile. So the configuration.yaml file, as we have said, that it's going to configure the Jenkins server as well as creates the job for the Jenkins, and we have written a load balancer application, so it's going to set up a load balancer in the Jenkins server itself. So I'll quickly pause the video for a while here until the installation is done. So the execution of the playback is completed, so we should be able to see a Jenkins server being configured at this IP address. Fill up the URL. So as we can see now, there are two separate builds, both for the Canary branch as well as the one for the master branch. So this is going to spin up a stable version of the code, and the underscore Canary job is going to spin the Canary instance in the EC2 console. So let's quickly pull up the logs for this one. So as we can see here, the build has been successful, the npm install part of it. Then later it's going to create the EC2 instance in the AWS console. So the second post build task is where we actually bring up the install the application in the EC2 instance. So this one is for the Canary instance. So if we go into the build configuration, this is where we mention the Jenkins server, which branch to look for while it builds the code. So I have this checkbox.io application code open. So we have two branches in here, one corresponds to the master and one for Canary. So I've made a change already in the index.html of the Canary branch of the checkbox.io application. So I made a small change for the h3 header. We change this to developers Canary test. Rather than the master branch, we have developers. Let's go look at the build logs. So the build has been successful for the Canary instance. So for the stable instance, the application is getting installed in the new visitor instance. Quickly pause the video for a while here while this gets completed. So the build for the stable instance is also successful. If we go into the EC2 management console and refresh the page, so we'll see two instances corresponding to the checkbox IO application. One that is the stable version and one is the Canary instance. Now these two boxes have different IPs. So this one is the stable instance. And if I just pull the Canary instance as well, so I have the developers Canary testing here. Now we have implemented a load balancer as well. So the Jenkins server, as we have mentioned, is configured with the load balancer itself. So since we need to have the ability to configure the IPs that the load balancer takes care dynamically, we have installed Redis server. So I'm logged into the load balancer machine now. So we have installed Redis in this machine so that we can quickly or dynamically configure the stable IPs as well as the Canary instance IPs. So I'll quickly pull up the Redis client and I'll push all the instances that are available we have into the Redis client. So the server list will contain all the instances which the load balancer will balance against, and we have a separate list for the stable servers list. So the load balancer will actually round robin use the round robin algorithm to load balance requests across the servers we have in the server list, and if there is any error or any 500 request or any alert is raised against the Canary instance, we are going to use the IPs that are there in the stable server list. So the load balancer IP is same as the Jenkins server. So it's running on 3000. So this is load balancing requests between .145 as well as .237 machines. So we have a stable as well as the Canary instance. If I reload it multiple times, we should be able to see the developers getting changed. So let's say there has been some discrepancy in the Canary instance and the application crashes for some reason. We should be able to see all the requests getting redirected to stable instance instead of the Canary instance as well. So let me log into the system. So I'm logged into the system right now, so I can see the process corresponding to the checkbox IO being run in the Canary instance. So let me kill this application. So I'm just emulating a scenario where the Canary instance application crashes. So if I reload this, I should not be able to see the application running at all. So if you go into the load balancer right now, every time we reload, it should be developers. We should not get the Canary instance requests at all. Since the Canary instance is not working right now, so the load balancer actually pushing all the requests to the stable instance. So let me pull out the code for the load balancer that we have implemented. So this is just a simple Node.js application. So we have a Redis client which gets connected to the Redis server that we have configured. So this is the server list that we were talking about, where we pushed all the available IPs that we have, and this is the list where the application contacts in case of any alert being raised. So it's going to redirect the request to the stable servers that we have. So if there is no alert raised, so it's going to distribute every time in a round robin fashion using the rpop lpush operation of the Redis client. So this is how we have implemented our Canary Release. Let's quickly show the diagram and grab it up. So we have maintained two branches in the Git repository, one that corresponds to the stable version and one that corresponds to the Canary instance. So whenever a developer wants to test the code in the production, he's going to push the code into the Canary instance. The Jenkins server is going to spin a new EC2 instance after a change has been made to this Canary branch. And the load balancer is going to distribute the traffic among these two instances unless there is an alert raised. If there is an alert raised, it's going to stop the traffic and redirect that has been sent to Canary and redirect it to prod instance, which is a stable version of it. So this is how we have demoed in this video.